Hey guys, what's up everyone? How are you people doing? Welcome to today's session, people. This is session number 5 of Light Chapter, and today we'll be talking about sign convention of mirrors and its magnifications as well. Welcome once again. My name is Anoop, and this here is the Vedantu 9th and 10th channel. Once again, before we get started, slap that like button and also make sure that you subscribe if you're new and join the squad so that you can be a part of all these elite groups. I mean, all the elite teachers, learn from the best and also be one of the best there is out there, guys. With that said, let us get started with today's session. So like I told you, today we'll be talking about sign convention of mirrors and magnification. Today I'll be making it clear about what are the different sign conventions and what are the formula for magnification, what exactly is magnification. All of that is what we're going to talk about in today's session. So I hope that you guys are excited for today's session and you guys are you guys are ready to learn something new. I'm really sorry if I'm fumbling a lot because it's a little late and I'm a little tired, so I'm really sorry if I fumble too much. Nonetheless, guys, let us get started with today's session. But as always, this is the code for today, guys. Failure is success if you learn from it. It's a very straightforward thing, guys. You cannot expect to become better if you don't fail at something. If you're not failing, that means you're not trying. So keep trying, and the failure that you get, whatever failure that you face, make sure that you work on it and improve it the next time. You cannot just repeat the same mistakes. Only a fool would repeat the same mistake, and a smart person would learn from that mistake and make sure that it does not come up again. Now, this is something which you should follow by your heart, because thing is this, guys, in your exams also we make a lot of mistakes when we're solving all these sample papers. So try to figure out what those mistakes are, analyze those mistakes, and try to correct those mistakes as well. Anyways, with that said, guys, let us get started with today's session. So sign convention and your magnification. But before that, guys, we had in the last session I'd given you homework. This was the homework. The size of the image is always smaller than the size of the object in dash mirror. Always. In which of that is it? It's going to be in a convex mirror. If you guys remember, I told you that in a concave mirror you can have magnified image or image of the same size, or you can have diminished image as well. But in a convex mirror, you're always going to get a diminished image itself, or image is going to be smaller than that of the object. So the right answer, convex mirror. I hope you guys got this right. I'm pretty sure that you did. So hats off to you people. Keep up the good work. With that said, let us get started with today's session, wherein we'll be talking about sign convention, starting with the spherical mirrors. Then we'll work our way through magnification of spherical mirrors as well. So here's the thing, guys. Let's take a concave mirror. A simple concave mirror. The object is placed somewhere at between infinity and the center of curvature. C here is the center of curvature. F is nothing but the focus, and P is nothing but the pole. First thing you have to understand is this, guys. All the distance in a spherical mirror is measured from the pole. So that is a reference point. For example, when you're walking from one place to another, you take a reference point. In the same way, here also the reference point is the pole. From the pole, you measure all the distance. So this distance to the focus is called as the focal length, which is represented as small f, which is the focal length. That is the distance between the pole and the focus of the mirror. And the r, that is nothing but the distance from the center of curvature to the pole, is called as the radius of curvature. So that would be the radius of curvature, which is represented as r, and u is nothing but the distance of the object, again from the pole itself. So this is the first one. Do not ever forget this, guys. Remember all these points one by one. The first one is that all of the distance is measured from the pole. The second thing is that any distance along the incident ray is considered to be positive. So generally what we do is that we always keep the object in the left hand side. So the distance that goes with the incident ray would be positive, and any distance which is in the opposite direction is taken as negative. So the distance that is in the direction of the incident ray is taken as positive, and any direction that is opposite to the incident ray is taken as negative. Now all these points are very important. So in the direction positive, opposite of the direction of the incident ray is taken as negative. Now I'll tell you where we are using it, so do not forget this, guys. So what I'm trying to say is this. See, guys, when an object is placed in front of the mirror, what will happen? The ray of light would basically go and strike the surface. It'll get reflected, and maybe because it's parallel to the principal axis, it'll pass through the focus. So here's what is the thing. Any distance that is in front of the mirror, because it's in the opposite direction of that of the incident ray, is taken as negative. So for both concave as well as convex mirrors, the distance, no, sorry, not convex mirror, because over there in front of the, okay, yeah, you know, the in front part would actually be the opposite direction. So let's talk about concave mirror. So in a concave mirror, you see that the distance in front of the mirror is taken as negative, and the distance behind the mirror is taken as positive. In front of the mirror is negative, in behind the mirror is taken as positive for a concave mirror. Remember this, guys, it's very, very important. If you want, take a screenshot of this, but keep it in your mind at all times, no matter what. So remember this, guys, in both, yeah, you can talk about convex. In fact, even in a convex mirror also, it's pretty much the same thing. So here this would be the reflecting surface. So yeah, for both concave as well as convex mirrors, you can say that the distance in front of the mirror is taken as negative, and behind the mirror is taken as positive. As simple as that. So for a concave mirror, in the case of a concave mirror, the focal length that we take, the distance from the pole to the focus, is called as a focal length. That is negative because it lies in front of the mirror. For a concave mirror, because the focal length lies in front of it. The same goes with the radius of curvature as well as the distance of the object as well. U, R, F, all of these are negative. Why are they negative? Because they lie in front of the mirror. On the other hand, if you talk about a convex mirror, the distance in front, again, here also the distance in front of the mirror is taken as negative, behind the mirror it's positive. But the thing is this, guys, in a convex mirror, the center of curvature, the focus, everything lies behind the mirror. So over here, the focal length and the radius of curvature, everything would be positive, but the image distance, sorry, the object distance would be negative because it lies in front of the mirror. Simple, people. Once again, I will be repeating everything at once. You can take a quick screenshot of that at the end. Don't worry about it. For now, just remember this, guys. For a convex mirror, the focal length as well as the center of curvature is going to lie behind the mirror, and so they are both positive. Whereas the image, also the object, on the other hand, lies in front of the mirror, and so the object distance is actually taken as negative. Now to talk about the mirror formula. Here's the thing, guys. All the ray diagram does, we have talked about all sorts of ray diagrams. Now the thing about ray diagrams is that it tells you where the image is found. But the problem with this is that it doesn't exactly pinpoint where the exact location of the image is. Is it 5 meters below? Is it 5 meters above? That distance is not exactly mentioned. So we have the mirror formula to solve that problem. So what is the mirror formula, you may ask? It's very simple, guys. 1 by V plus 1 by U is equal to 1 by F, where 1 by V is the image distance. V stands for the image distance. All right, the image distance. U is nothing but the object distance, and F would be the focal length. So if you know any of the two values, either if you know the focal length and the image distance, you can find out the object distance. If you know the object distance and the focal length, you can find out the image distance. If you know the image distance and the object distance, you can find out the focal length. So any of these things, if you know, you would be able to find out one, or if you know two of the values, you'll be able to find out one of them. So V is the image distance, F is the focal length, and U is the object distance. As simple as that. If you use this formula, guys, you'll be able to find out the position of the object or of the image, or even if you want to find out the focal length where you have been given the value of both image distance and of the object distance, you could find this out as well. Very simple. Remember this, guys, because all of these would be asked as 2-mark, 3-mark questions. So keep this all in mind. So once again, what is the mirror formula? 1 by U plus 1 by V is equal to 1 by F. Now the lens formula would be different. For now, just remember this, guys. 1 by U plus 1 by V is equal to 1 by F. Simple. All right. Now let's move ahead and understand what is magnification. Here's the thing, guys. In the case of a concave mirror, we saw that sometimes the image is actually bigger than the size of the object. So magnification tells you what is the ratio of the image to that of the object. What is the ratio of the size of the image to the ratio of size of the object? The comparison between the two is what magnification tells you. So if you want to find a magnification, it is the ratio of the height of the image to the height of the object, where HI stands for the height of the image and HO stands for the height of the object. So if you find out the ratio, you'll be able to find out what is the magnification of that particular mirror. So M, which stands for magnification, is equal to HI by HO, which tells you what is the height of the image. Now, There is another condition which I'll be telling about in a minute, but for that, guys, let's understand a little bit more about magnification. If you find the magnification is equal to 1, this means that the image and the object is of the same size. If you look at it, so m is equal to hi by h naught. So if m is equal to 1, so what will be? 1 is equal to h1 by h naught. So you can take h naught to the other side. What will you get? Hi is equal to h naught. Very simple. This is a condition where the object is kept exactly at the center of curvature. So at that time I told you, if you remember the ray diagram, I told you in a concave mirror, when you keep the object on the center of curvature, then the image will also be formed exactly on the center of curvature itself, and it will be of the same size. So here, this is the condition that you actually satisfy when you talk about the object being placed at the center of curvature. If in case the object, the magnification is greater than that of 1, that means that the image size is greater or larger than the object size, which means that the image is magnified or the image is enlarged, and the object, basically the object is smaller. Like in the case when the object is placed between the center of curvature and the focus, you can see that you get a magnified image. So here you can see that the size of the object, is actually way more smaller than the size of the image. That is when m is greater than 1. And when m is less than 1, it's just the opposite. That means that the size of the object is far more greater than the size of the image. Like in the case of when the object is placed between infinity and the center of curvature, you find that the image is formed between the focus and the center of curvature, and the image is going to be diminished. That's what we say, it's diminished. That means that the value of m is going to be less than that of 1. As simple as that. Now, this is not the only condition, guys. There are a lot of other conditions as well. We've seen all of that in the previous session, so please watch the video of that and help me understand if you guys have understood the topic or not in the comment section below. Anyways, with that said, let's move ahead and understand a little bit more about sign convention. So we talked about left and right on the principal axis. What about top and bottom? Anything that is above the principal axis is taken as positive, and anything that is below the principal axis is taken as negative. For both concave and convex mirrors, it is the exact same thing: above positive, below negative. Simple as that. That's all. So in conclusion, guys, I want everyone to take a quick screenshot of this, because this is the entire thing that I just told you in one class. So when you talk about the sign convention of the object and the image distance, in front of the mirror, you take it as negative. Behind the mirror is taken as positive. If you talk about the height of the object, above the principal axis is taken as positive. Below the principal axis is taken as negative. One glance, everything done. That's all, people. Anyways, one more thing is this, guys. Magnification and sign, the sign, that is the sign of magnification, whether it's positive or negative, and the size and the orientation, that is whether it's above or below. All of this gives us an idea of where the object or where the image is exactly. It'll pinpoint where the image is. But sometimes you might not be given the height of the object or the height of the image as well. So in this case, how do you find the magnification? Don't worry, guys, we've got it covered. The formula for that is m is equal to minus v by u. So if you use this formula, minus v by u, you'll be able to find out the magnification if in case the height of the object and the image is not given. So you can use the distance of the object and the distance of the image to find out what is the magnification. Again, what's the formula? M is equal to minus v by u will give you what is the magnification if in case the height of the object is not given. Very simple. I know you did. All right. Anyways, guys, so with that said, let us now understand and solve some questions. But before we solve the questions, guys, I have a very important announcement to make. You guys know about it. When majority of all of those new people, this one's for you guys. Listen to me very carefully, because this is going to definitely help you guys in the future as well. So here's the thing, guys. We had actually taken up a survey asking you guys what are the problems that you guys are facing, especially during this quarantine time where you don't get to go to school, and there are a lot of problems that you guys are facing that needs to be addressed right now, because majority of you guys are going to give your boards in a couple of months and you guys are scared about it. I totally understand it. So these are the things that you guys came up with. It's totally from your side, nothing that we came up with, and I'm pretty sure that every one of you guys would be able to relate to this. The first problem, doubts, right? Because you're not able to solve your doubts. There are no teachers to go and ask you doubts. Physically, your friends are at home, so that's also not an option. So how do you get your doubts cleared? Secondly, notes. How do you download the notes? Because you guys are watching all sorts of videos on YouTube, but how do you download the notes so that you can utilize the best of thing that is written on that board? Thirdly, tests and assignments, because you don't really want to go and write the exam without giving those sample papers, without giving some tests to check if you have really understood the concept, to check whether you are capable of scoring 90% and above. I'm pretty sure that everyone is worried about that as well. Fourthly, competitive exams, because I'm pretty sure that you guys are also looking forward to write your competitive exams like your NSOs and KUPY and NTSE. You guys have been preparing for a long time now. So how do you prepare for those competitive exams as well? Choice of your own schedule, because yes, that is also a big problem. You're not, let's say that you're someone who doesn't want to study at 5 o'clock. You're forced to study at 5 o'clock, which is something that I'm pretty sure that you would not be able to focus at that point of time. So how do you choose your own schedule? That's another problem. And also choice of your own language, because not everyone understands English, not everyone understands Hindi. So how do you solve all these problems, right? I know you must be wondering it too. Now that I've told you, you must be thinking about it again now. Here's the thing, guys. We at Vedantu are proud to say that we have solved each and every one of these problems. You know, inside the class, you will not just have one teacher, you will have two teachers. You will have the master teacher to help you clear your doubts, to help you understand the concept, and you'll also have the class teacher to help you clear your doubts. So you get personalized attention, making sure that your doubts are cleared inside the class itself. You can download all the notes of each and every session, everything that is written, handwritten notes of all the teachers. You can download it. With that, you can also watch the recording. So if in case you miss out a session, you can always watch the recording and aware yourself of what and all have been done in the previous session as well. You can also attend you have regular tests and assignments, which tells you where you're going wrong. And based on these tests and assignments, you'll also be getting a detailed report card as well, a personalized report card, which tells you where are the topics that you're good at and what are the topics that you're bad at. Apart from that, you'll also be, trained for your competitive exams. You can choose your own schedule. There's no need to worry about timings anymore. You can choose your own schedule, and in that time, you can choose the teacher that you want to study with and study with that teacher alone. And apart from that, you get choose your own language, guys. Now here's the thing, we are offering sessions in both English as well as in Hindi. So if you're someone who's more comfortable in English, then you can go with that. If you're someone who's more comfortable in Hindi, then you can go with that as well. So both these options are given. Now again, we're not going with the regional languages, because there are so many regional languages out there. Maybe in the future we might, but for now it's limited to English and Hindi. I'm pretty sure that every one of you guys understand either English or Hindi, so this one's for all of you guys out there. Anyways, people, so apart from these, you'll also be getting unlimited live classes. That means you can attend how many live classes you want, all micro courses and crash courses for free, performance report card, and personalized attention with the help of the class teacher as well. So what are you going to do? I know you must be asking this question. Click on the link that is given in the description below. Once you click on that link, this is what you're going to get. They'll ask you which grade do you belong to. From 1 to 12 is the option. Let's say you're in 10th grade. Once you click on 10th grade, they'll ask you which board do you belong to, CBSE, ICSE, or Maharashtra. Let's say that you select CBSE board, then you get this particular screen that you see right now. Everything that I just told you in detail. You can pause the video and watch it if you want to, guys. So all of that, everything is given right here. So what you have to do is basically click on get subscription. Once you click on get subscription, this is what they're going to ask you, whether you want to go with the 1 month program, the 2 month, 3 month program, or the 6 month program. Let's say you want to try for the next 30 days and see how it works out, and then decide whether we're going to do it further or not. So for the next 30 days, if you choose to go with it, the base price is 4,000 rupees. Like a lot, no? It's a lot of money. But don't worry, guys, you'll get a primary discount on that, and you'll be getting a discount of about 1,300 rupees. So essentially what you'll be paying is 2,699 rupees. And on top of that, if you want to save more money, enter the coupon code AMPRO. Click on I have a coupon code and enter this coupon code AMPRO. Additional 500 rupees, you'll be getting a discount on that. And what you'll be paying is 2,149 rupees, 59 rupees for the next 1 month. Let's say you want to go for the 3 month course. Here's the thing, guys, for the 3 month course, the base price is 10,000 rupees. But again, don't worry, you'll be getting a primary discount on that, and you'll be paying around 6,999 rupees. On top of that, if you want to save another 1,400 rupees, enter my coupon code AMPRO. You'll get additional 1,399 rupees, and you get the price down to be 5,599 rupees. And if you want to go for the 6 month course, the 6 month course is about 16,000 rupees. But again, it's a lot of money. Don't worry, guys, you'll be getting a discount on that. You'll be paying around 11,499 rupees. On top of that, if you want an additional discount, enter the coupon code AMPRO and again get another 2,200 rupees discount. And what you'll be paying is 9,199 rupees. Now here's the thing, guys. I'm pretty sure you're wondering, sir, is it worth it? Trust me, it is, guys, because you'll be learning with one of the best teachers in the world. Trust me, they are one of the best teachers in the world itself. And also, if you think about it, each and every session you can attend how many live classes you want for that price. So I'm pretty sure that it's a very good deal. Check out the link. It's given in the description below. And do not forget the coupon code AMPRO and let me know what you think about it as well. With that said, guys, let us get back into the question now. Let's solve some questions. See what have we done so far. Now, I want all of you guys to let me know what is the answers in the comment section below. Do not just copy my answers. That is not something that is not fair. I'll start darting everyone. Don't do that. Please make sure that you start solving the questions and do it by yourself and put it on the comment section below. Here's the first question, people. Radius of curvature in case of a concave mirror is what? And the focus of in case of a convex mirror is what? Is it positive, positive, negative, positive, positive, negative, or negative and negative? The radius of curvature of a concave mirror and the radius and the focus of a convex mirror. Here's the thing is, for a concave mirror, the radius of curvature lies in front of the mirror, which means that it's going to be negative because anything in front of the mirror is negative, anything behind the mirror is positive. The focus of a convex mirror is going to lie behind the mirror and hence it's going to be positive. So what would be the right answer? Option number B, no doubt about it. It's going to be negative for the first one and positive for the second one. Very simple, right? I know. Second question. Mirror formula is valid for what? Only concave mirrors, only convex mirrors, plane mirrors, or all spherical mirrors? The mirror formula, which is 1 by U plus 1 by V is equal to 1 by F, is true for which of these? Very simple question again. The right answer? It's all spherical mirror, guys. Both concave as well as convex mirror, there's no exception. You can substitute, you can use that formula to find out either the focal length or the distance of the object or the distance of the image, depending on what you want to find for both concave as well as convex mirrors. Very simple question again. Third question is, what is the sign convention of U and F in the given figure? It's a concave mirror, so what will be the sign convention of both the focal length as well as the object distance, which apparently is 25 and the focal length is 10? The answer, it is what? It is going to be negative. Both are negative because both of them lie in front of the mirror. In a concave mirror, both of them lie in front of the mirror and hence both of them would be negative. Very simple question. Fourth question. I know all the questions are very simple, guys. You just need to focus a little and you'll be able to do it very, very aram se. For one curved mirror, the image height is given as 10 centimeters and the object height is given as 5 centimeters. What is the magnification? Is it 22, 0.5 or 10.5? Which of these do you think is the right answer? Again, how do you solve this question? M is equal to h dash by h. H dash is given as 10, h is 5, that is h dash is image, the height of the image, h is the height of the object, 5 2s are 10. So what is the answer? It's option number B. Very simple, which means that the object, the image is going to be magnified, or it's going to be twice as magnified as that of the object. So whatever is the size of the object, 2 times of that would be the size of the image as well. Just like how you see right now, 5 is the size of the object, 10 would be the size of the image. Very simple. Anyways, guys, with that said, here is your homework for today. Let me know what is the answer in the comment section below again. The homework for today is this. Based on sign convention, object distance U is always what? Based on the sign convention, the object distance U for both concave and convex mirrors, what is that going to be? Let me know in the comment section below. Thank you for joining, guys. Once again, leave a like, subscribe to the channel, be a part of the squad. Thank you for joining. See you guys in the next one. Until the next time, this is Anoop. Peace out, people. Take care of yourself. Stay safe. Bye-bye.